Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about recommender systems. This episode is based on a tech blog titled Improving Embedding-Based Candidate Generation for Recommender Systems with a Two-Tower Model, published by Glassdoor's engineering team. Throughout this episode, we will explore this topic from both the business and technical angles. Now, let's dive in. On the business side, let's first take a look at the problem to be solved. Glassdoor is a platform where millions of professionals research companies, read workplace reviews, and engage with career-related content. One of its key products is Community Feed, where users discover discussions about interview preparations, workplace culture, career growth, industry trends, and many other professional topics. At any given moment, thousands of posts are competing for users' attention across hundreds of communities, making content ranking a critical part of keeping users engaged. A key challenge in this ranking system is deciding which posts should even be considered for a given user, and doing so within very tight latency budget. This is known as the candidate generation problem, retrieving a small set of promising posts from a massive pool of available content before more computationally expensive ranking models take over. Candidate generation acts as a gateway to the entire recommendation pipeline. If relevant posts are filtered out at this stage, no downstream ranking models, no matter how sophisticated they are, could bring them back. A straightforward solution here for the candidate generation might be to recommend the most popular posts, or retrieve content based on similar topics. In practice, however, neither approach works particularly well. Popularity-based approach tends to concentrate attention on a small number of viral posts, making it difficult for fresh or niche content to be surfaced. Topic matching approach is also too coarse to capture individual preferences. Two users may both be interested in software engineering as a topic, yet one may consistently engage with interview preparation, while the other is far more interested in workplace culture or career development. On top of that, new posts are constantly being created, and user interests evolve over time. So the system must generate relevant candidates in real time for every user and every session. Now that we've understood the business problem to solve, let's dive into the technical side to see how the team tackled this challenge. The standard industry solution for candidate generation retrieval is called approximate nearest neighbor search over dense embeddings. The basic idea is to embed users and posts into the same vector space, index the post embeddings offline, and then retrieve the closest post to a user's embedding at serving time. This pattern is well established across the industry, and what ultimately determines success of this approach is usually the quality of the embedding themselves. The team's initial attempt relied on off-the-shelf sentence transformers. These are solid general-purpose models, but they were never trained on Glassdoor's actual user behavior. They capture mainly the text similarity, not the user's preferences similarities. As a result, there was a significant gap between what the model learned and what was needed for highly relevant content retrieval. To address this gap, the team moved to a two-tower neural network trained directly on users' interaction data. This is a widely used retrieval architecture that has been adopted by many tech companies. One of the tower encodes the user's information, while the other tower encodes the post information, with both towers mapping into the same vector space. The training objective is straightforward, which is a user's embedding should sit closer to posts they engaged with than the posts they didn't. When the model is trained, post embeddings can be pre-computed offline and stored in a vector database. At serving time, the system only needs to generate a user embedding and run an approximate nearest neighbor search against the indexed post embeddings. Most of the heavy computation happens ahead of time, which keeps retrieval fast enough for production workload. While this two-tower model is a proven industry pattern, the team made two customizations that make it work well in their specific domain, and that is the most interesting part. The first decision was around negative sampling. Training a two-tower model requires negative examples, which are the posts that a user did not engage with. A common approach is to use in-batch negatives, where posts associated with other users in the same training batch are treated as negatives. This is efficient and works reasonably well. However, the problem is that this approach naturally overrepresents popular content. Popular posts appear in more interactions, which means they show up more frequently in training batches. Over time, the model learns strong representations for popular posts, but may learn much less about the long-tail content. The team addressed this challenge by mixing in randomly sampled posts drawn from the broader content corpus alongside the in-batch negatives. This forces the model to learn representations across a much wider range of content, rather than repeatedly focusing on the same highly popular posts. For a community platform where niche discussions matter, this is a very meaningful practical improvement. The second decision was adding a self-supervised learning objective. This addressed a problem that shows up in almost every recommendation system, which is sparse data. Many users have limited interaction histories, and many posts receive relatively little engagement. If the model only learns from clicks and interactions, it struggles precisely in those situations where data is scarce. The team's approach was to create augmented views of users and posts by randomly masking portions of their input features. The model then learns what different masked versions of the same user should produce similar embeddings, while representations of different users should remain distinct. This creates a second learning signal that doesn't depend on engagement labels. Instead of learning solely from observed behaviors, the model also learns from the underlying structure of users and posts. That additional signal helps the system generalize better, particularly for sparse users and long-tail content, where interaction data alone may not provide enough information. With these two improvements, the results were quite solid. Offline retrieval metrics improved by roughly 40% compared to the sentence transformer baseline. More importantly, the online experiments showed a statistically significant 5% increase in engaged users and clicks per user. The feed diversity also improves, suggesting that the system was doing a better job of surfacing a broader range of relevant content, rather than repeatedly recommending the same popular posts. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we discussed Glassdoor's approach to customize the two-tower model for its specific environment. The gap between generic semantic embeddings and behavior-driven embedding turned out to be very meaningful, and closing that gap requires thoughtful decisions around training data, negative sampling, and auxiliary learning signals. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.